Alright everybody, what we're going to take a look at today is the introductory topic to section 5.6, which is going to be called the discriminant. And we'll go over what that is and why that's important and how we use that in solving quadratics throughout the lesson. But for today, to start, what I want you guys to do, pause the video, answer this warm-up question, just identify the A, B, and C values for that for these two quadratics. Okay, so pause the video and go ahead and do that. Alright, so let's check our answers. Again, remember, A is the constant in front of x squared, B is the constant in front of x, and C is just the constant in the quadratic. So taking a look at this one, everything is lined up perfectly. A would be 2, B would be -3, C would be 8. Remember, if this is not just 3, it would be -3. Okay, for that B value, we have to include that sign as well. Here we have something that's out of order. Remember, A is the constant in front of the x squared term, so this would be -1. We do not have an x term, so that's like 0x, so our B would be 0 and C would be 5. Okay? What we're going to do today, we're going to use the discriminant to determine the number and type of solutions to a quadratic equation. So we're not really going to go through and solve them, but we're going to identify what kind of solutions we're going to have and the number of them. Okay? And this will end up helping us really for the quadratic formula, which we're going to get into. Now, the value b squared minus 4ac, okay, b squared minus 4ac, what that is called is the discriminant. So remember, when we had ax squared plus bx plus c, what we're going to do is we're going to take those values and plug into b squared minus 4ac. And if we look at these rules here, okay, this is what's going to be really important, and this is going to be a piece of the quadratic formula, which is going to be a way we solve equations, which we'll do moving forward. And this will make a little more sense when we look at the quadratic formula as a whole. Why it's two real, one real, or two imaginary solutions. But for today, what we need to make sure we have down is these three ideas. All right. If our discriminant, so our b squared minus 4ac, if it is positive, so if it's greater than 0, we're going to have two real solutions. Okay, so that may be something like 3 and 1. All right, two real numbers. If b squared minus 4ac is equal to 0, then our equation is going to have one real solution. Okay, and I'll show you what that looks like on a graph in a minute. If it's less than 0, so if it's negative, we're going to have two imaginary solutions. Okay, so that means we're going to have to include I in some form of it. Okay, now what does that mean in terms of a quadratic? So if we have two real solutions, this is what it looks like. Remember, solutions are when we intercept the x-axis, so our x-intercepts. This would have two real solutions because it intercepts at -2 and +2. This would be a situation where b squared minus 4ac is positive. So you may get, when you plug in b squared minus 4ac, you may get 7. And what that's going to tell you is, okay, I'm going to have two real solutions. That doesn't mean 7 is the solution. What it means is that we're going to have two real solutions, because all the discriminant tells us is the number of solutions and the type. So this would be two real solutions. This would be two imaginary solutions because it does not intercept the x-axis. Okay, it does not intercept the x-axis. So what that means is it's going to intercept the imaginary axis, which we talked about in class. But again, we see it does not intercept here, so there is no real answer. There's no real number where y is going to equal 0. So that means we're going to have two imaginary answers. Okay, again, it tells us the number and the type. Lastly, all right, we're going to have one real solution. Okay, and that's when our vertex intercepts the x-axis. So we see it only touches at one point. So we would have one real solution, and that's going to be when b squared minus 4ac ends up equaling 0. Okay, when it's actually set equal to 0. And for the two imaginary solutions, it would have to be negative. Okay, so understanding that, a solution is where we intercept the x-axis, and if we're going to have real ones, then it will actually show up on the graph, like we had here. It'll be two intersections of the x-axis. Imaginary, it doesn't intercept the x-axis. Here, it's going to intersect the x-axis at one point. So it's going to just touch at one point. That would be one real solution. A real solution is an x-intercept. Okay, so now, what we'll take a look at. Use the discriminant to determine the type and number of solutions. So x squared minus 6x plus 10. What we're going to need to do is we're going to need to plug into b squared minus 4ac. So again, identify a is 1, b is negative 6, c would be 10. Plug into this formula. Okay, so we would have negative 6 squared minus 4 times 1 times 10. Negative 6 squared would be 36. We multiply all of these things together. Alright, 10 times 1 would be 10. Alright, when I multiply these two, it will give me 40. Alright, so I have 36 minus 40. That's going to equal negative 4. Well, that's telling me, okay, it's going to fit into one of three categories. Either our discriminant value is going to be positive, it's going to be negative, or it's going to be equal to 0. Okay, if I look at this, this is negative. So what that's going to tell me, if it's negative, we're going to have two imaginary solutions. So, use the discriminant to determine the type and number of solutions. Well, all you're going to say is, alright, I know I'm going to have two imaginary solutions. Okay? That's what I know I'm going to have two imaginary. And that's all I have to say for now. I don't need to find out what those are going to be. And I could do that, and that's what we're going to do moving forward. But I just need to identify what kind of solutions I'm going to have. So that would be a situation if we look. Sorry, I got to go through all my papers here. That would be a situation if we looked at the graph like this. It would not intersect, or sorry, we would not have any x-intercepts. Okay, we would have no real x-intercepts. So we would have two imaginary answers. Alright, and that's all it's looking for us to do. If we take a look at these ones, okay, I'll go through one, and then I'll have you guys practice the second one. Again, you're looking at b squared minus 4ac. A here is 1, b is negative 6, c would be 9. Okay, I plug into my formula. Negative 6 squared minus 4 times a times c, and I simplify this. So we would have 36 minus 4 times 9, because 1 times 9 would be 9. 36 minus 36 would equal 0. Okay, so my discriminant equals 0. What that tells me is I'm going to have one real solution. Okay, and what that looks like on a graph, again, that means the vertex is the only point that touches the x-axis. So it would look like this. Okay, I'm not saying this is the exact one, but it would look something like that. Okay, so you would get one answer. Now, if you wanted, what our one answer would end up being, you can end up calculating that using the quadratic formula, which we will move forward and do. Okay, what I want you guys to try before you get into some classwork is just identify using the discriminant, determine the type and number of solutions for this here. Alright, give it a try. So pause the video and see what you can do. Alright, if we take a look at this example that you guys just went through and did, again, identify a, b, and c, plug those values into the discriminant, which is b squared minus 4ac, and we identify, we just kind of simplify it and see what the value is. Here we got 4. All we're looking for is it positive? Is it equal to 0? Or is it negative? It's has to fit into one of those three categories. This one was positive, so what that tells me is it's going to have two real solutions. And again, that's all I have to answer for now. I don't need to actually figure out what those solutions are going to be. That's going to be something that we'll do moving forward. That means it would look something like this. We would have two real x-intercepts. Okay, we would see the two values where y equals 0. And that's what we're looking for. We're identifying the number and type of solution we're going to have for a quadratic expression. Okay? Now, for the rest of the period, what I want you guys to do is you're going to work on the homework worksheet. All right, so it's going to be, again, just practicing the discriminant using b squared minus 4ac to identify, like, all right, how many solutions are we going to have and what kind of solution are they going to be. Give it a try.